In this video, we will learn how to conduct Cox proportion hazard regression with time-varying covariate with EZR. Motivating example is from the Stanford heart transplant data. 2 patients were followed from time of registering to the wait list for the heart transplantation. And patient 1 had a transplant at day 5, and then patient 2 and died at day 3 without having transplant. And for patient 1, the 5 days before the transplantation should be considered as not having transplant, and the days after the transplant should be considered having transplant. As you see in this example, the status of exposure is changing over time, and survival analysis have to consider time-varying status of the covariate. Otherwise, the result may face the fatal bias called immortal time bias. There are 2 ways to create a dataset in Excel for time-varying covariate. In the single row per person format, data from a single patient is entered within the row, and time is considered the time of death, and time trend is considered time of transplantation, and EV trend is considered as an indicator if a patient eventually had a transplant. And the status variable indicates whether patients are being deceased or survived. In the multiple rows per person dataset, patient who had transplant data are entered in the 2 lines in Excel. So ID number 3 person, transplant occurred at day 1. The variable called start indicate start of follow-up interval, and variable called stop indicate end of follow-up interval. So you see, for the ID number 3, this person from day 0 to day 1, this patient was classified as not having transplant, although for the interval from day 1 to day 16, this patient is classified as having transplant. And at the end of the interval between day 1 to day 16, this person died. The variable event indicate if the patient died at the end of the interval. And the variable transplant indicate whether this patient had a transplant at the start of the interval. And EZR actually uses this single row per person data format. And we use dataset called heart1.csv. Downside of this data format, the covariate cannot vary over time. Multiple row per person data format, since the data can be entered within the multiple rows, so the covariates such as severity can be entered at the beginning of the follow-up and then also at the time of transplantation. So before conducting Cox proportion hazard with time-varying covariate with EZR, if the time of transplantation variable is missing for patient who didn't have a transplant, we need to replace this missing value with time of end of follow-up. Go to active dataset and choose variables, create new variable. And then we are now going to create a new variable called timetran.new. Here you type if else parenthesis EV underscore tran equals 0, comma, time tran, and close parenthesis. So this means if the EV underscore tran is 0, this means patient did not have transplant. Assign timetran.new variable with time variable. And otherwise, allocate timetran. And this is the time of transplantation. And then once you create this variable, and we need to renew the active data set. To do that, go to active dataset and then choose Save or Export Active Dataset, Renew Active Dataset. Now let's perform Cox regression with time-varying covariate. Go to Statistical Analysis, Survival Analysis, and Cox proportion has a regression with time-dependent covariate. And then include a time variable and then also status variable here. And if your analysis do not have time-fixed covariate, keep this box as empty. And here is where we put the time-varying covariate. And we choose timetran.new. And EZR can take up to 2 time-dependent covariate. So this box, we will pick the ones time-varying covariate. The status change from 0 to 1. And then use this box if your time-varying covariate status change from 1 to 0. And I personally recommend using EZR only where you have one time-varying covariate. The status change from 0 to 1. And for the analysis, including time-varying covariate status change from 1 to 0, I do not recommend using EZR. Using multiple rows per person approach is much simpler, although we have to do programming for this. And I will explain this for the later video. So let's do the analysis with EZR. Let's import data. So first go to active data set and variables. Create new variable. Time tran.new. Here, if else, if time tran. Okay, and let's check the data. And here is new time tran variable. Okay, and now let's renew data set. And go to Save or Export Active Dataset, Renew Active Dataset. Okay. And go to Survival Analysis with Cox with Time-Dependent Covariate. And here put time. And here put Event Variable Status. And since we do not have time fixed variable, here if you like to adjust for age, and you could put age in here. But for now, we do not adjust anything. Just include time-dependent covariate. Okay, and click OK. And this is the result of Cox regression. And let's see, Monto, Bayer, and plot equal 1. Okay. And this will create Kaplan-Meier curve. The wrong way of doing this analysis: if you conduct regular survival analysis by ignoring time-dependent nature of covariate, analysis will be heavily biased. Let's do the wrong analysis. Go to survival analysis and let's go to Kaplan-Meier survival curve and log-rank test. This is just a normal way of doing Kaplan-Meier analysis. And then you pick time and status. And then here, if you force patients to be in one of the either category, either ever being transplant or not receiving transplant, and then do regular survival analysis, okay, Kaplan-Meier will look like this. And then this wrongly indicate effect of the transplantation. And this analysis does not mean the transplantation will help patient to survive. Otherwise, this analysis is obviously wrong, because this analysis considers the time before transplant wrongly as time after having transplant. This analysis is heavily biased with an immodal time bias, and we actually do not know whether the transplant help patients survive or actually being survived help patients to get a transplant. So please do not do this type of analysis in the situation the exposure status change during the follow-up time.